Welcome to the DIY Honda Garage channel. The DTC P2237 indicates that there is a high voltage condition in the IP circuit of the air-fuel ratio AF sensor 1. This sensor is critical for measuring the air-fuel mixture to ensure optimal combustion and emissions control. It is typically located in the exhaust system and communicates with the powertrain control module, PCM. When the PCM detects that the IP circuit is open, it triggers the DTC, signaling that there's a potential electrical fault in the sensor or its wiring. Addressing this issue promptly is vital to maintaining vehicle performance and compliance with emission standards. The error description for DTC P2237 states that the self-diagnostic function of the A-field sensor 1 identifies an open IP circuit. The A-field sensor, placed in the exhaust stream, measures the proportion of air and fuel to provide feedback for optimal combustion. This sensor plays a vital role in the engine management system by influencing fuel injection and ignition timing. The powertrain control module, PCM, uses the information from this sensor to adjust engine parameters. If it finds an abnormality, specifically an open circuit, it stores the DTC, indicating that further inspection of the circuit, the sensor, and its connections is necessary for proper diagnosis. The potential causes for DTC P2237 include an open wire in the IP circuit, which can occur due to physical damage or corrosion. A malfunctioning AF sensor itself may also cause this DTC, leading to erroneous readings sent to the PCM. Lastly, there may be issues within the PCM components, which could prevent accurate processing of sensor data. Correctly identifying the root cause is crucial, as it determines the necessary repairs or component replacements. Each of these factors affects the vehicle's overall performance and emission control, making precise diagnostics essential. When encountering DTC P2237, symptoms may include reduced engine performance, as the engine may run inefficiently due to incorrect air-fuel mixture adjustments. Increased emissions can occur, since the sensor's inability to report correct data can lead to poorer combustion. Additionally, the check engine light will illuminate on the dashboard, signaling the driver that there is a fault that needs addressing. Attention to these symptoms is essential, as ignoring them may result in further damage to the vehicle or increased environmental impact. Understanding these indicators can help drivers take timely action to diagnose and remedy the situation. The first step in troubleshooting DTC P2237 involves starting the engine and maintaining a speed of 3,000 RPM without any load until the radiator fan activates. This step is crucial, as it helps to establish a normal operating condition for the engine, allowing the technician to observe any discrepancies in the AF sensor's performance. Once the fan is on, letting the engine idle provides an opportunity to measure how the AF sensor responds under varied conditions. This procedure is essential for confirming that the engine and sensor are operating correctly before moving on to other inspection techniques. It sets the stage for diagnosing whether the circuit or sensor itself is at fault. In this step, the technician will disconnect the AF sensor, sensor 1 connector, and the PCM connector before proceeding to inspect the IP open wire. It's essential to ensure that the AF sensor connector is disconnected to eliminate interference during testing. Also, the PCM connector must be disconnected to test if the circuit to the AF sensor is intact. Performing this inspection involves checking the resistance across the terminals for continuity. Ideally, there should be less than 1 ohm of resistance across the open wire circuit. If the resistance exceeds this value, it indicates an issue within the wiring that needs further attention before considering the components themselves. In this step, conducting a confirmation procedure will help verify the condition of the AF sensor. After the preparatory disconnection of the AF sensor connector, the technician will perform necessary tests to assess the output voltage. The engine must be running for this test to ensure active readings. The expected voltage should be approximately 0.2 volts or higher when the sensor functions correctly. If the voltage reading is abnormal, this may indicate a malfunction in the PCM, which may not be processing AF data correctly. Understanding the output from the sensor enables a better diagnosis of whether the AF sensor or PCM is the contributing factor to the DTC. In the final step of the troubleshooting process, if the previous inspections confirm that both the external circuit and PCM are functioning correctly, it is likely that the AF sensor, sensor 1, is the issue. Conducting a comprehensive inspection of this component involves evaluating its operational status and performance in reading the air-fuel mixture accurately. If the AF sensor fails to provide correct data after all prior checks, it is concluded to be the faulty part that requires replacement. This step is crucial as it finalizes the root cause of the DTC, ensuring all repairs made will address the original issue effectively. After completing the necessary repairs or component replacements, it is vital to clear the DTC from the PCM to reset the diagnostic system. This action clears the fault memory, allowing the vehicle to run a new diagnostic cycle. It's crucial to monitor the vehicle's performance during a test drive to ensure that the repairs were successful and that the check engine light does not re-illuminate. Performance metrics may be evaluated to confirm the effectiveness of the AF sensor and overall engine management, ensuring that the vehicle runs smoothly without triggering any additional codes showcases the thoroughness of the repair. Once confirmed, the final step is ensuring the vehicle meets emission standards post-repair. Preventive maintenance is crucial in avoiding issues related to the A5 sensor like DTC P2237. Regular inspections of the sensor and associated wiring can catch early signs of wear, damage, or corrosion. It's recommended to include checking the integrity of electrical connections and the sensor's operational state during routine maintenance. Furthermore, monitoring overall engine performance can help identify discrepancies before they become significant faults. Understanding the vehicle's behavior can be a predictive measure against future issues. Establishing a maintenance schedule ideally reduces the risk of sensor failure or circuit issues, ensuring long-term reliability. In summary, DTC P2237 signifies a high-voltage fault in the IP circuit of the AF sensor, sensor 1. Understanding the origins of DTCs is essential for proper troubleshooting. Following a systematic approach ensures every component connected to the AF sensor is inspected thoroughly before concluding which part needs repair or replacement. Continual monitoring and preventive maintenance practices can help mitigate the reoccurrence of similar issues, ensuring optimal engine performance and emissions compliance. By adhering to these guidelines and promptly addressing any notification from the vehicle's diagnostic system, owners can reliably maintain their Honda CR-V's performance and efficiency. Please like and subscribe to the channel. See you next time.